Section 6.4 Derivatives of Logarithmic Functions Web Work Problems. Problem 1. Let fx equals natural log x power 6. Find its derivative, evaluate its derivative at e squared. Fx is 6th power of natural log x. So we need to use chain rule. The 6 comes down, power reduces by 1 times derivative of natural log. Derivative of natural log is 1 by x. So what did we do? We used chain rule. So combining it all together, you have 6 5th power of natural log x over x. That's your derivative. Derivative evaluated at e square, all I need to do is substitute e squared here. So you see, you can think of that square, that 2 comes out, and you're left with natural log of e inside. Natural log of e is simply 1. So 2 to the power 5 is 32. There is a 6 outside. 6 times 32 divided by e squared. So I can calculate it or I can simply substitute it. So first, derivative. I have a numerator and a denominator. So 6 natural log x power 5 and divided by x. That is derivative. What about evaluation of derivative at e squared? You have 6 times 32, the entire thing divided by e power 2. Let's check. Correct. Next problem. Let fx equals negative 3 natural log cosine x. Find the first derivative and the second derivative. Okay, so let's see. Well, obviously we need to use chain rule because I have natural log of cosine x. With a negative 3 outside, that's just a constant. So derivative is negative 3 stays. Derivative of natural log cosine x, 1 over cosine x, and then times derivative of cosine. That's a negative sign. So you see there is a negative and a negative. You have 3 sine x for the numerator and cosine x to the denominator, which is 3 tan x. That's the first derivative. Second derivative, what is derivative of tan? Secant squared. So 3 secant squared. So we have first derivative is 3 tan x. Second derivative is 3 secant squared x. All right, let's check. Good. Next problem. Fx is natural log of 5x plus 8. Find f prime x and use interval notation to give the domain of natural log. All right. First, let's figure out the domain. Well, you see, a domain of natural log is positive real numbers. So the argument has to be greater than 0. In other words, x has to be greater than, well, negative 8 divided by 5. X has to be greater than negative 8 over 5 means the interval, the domain of fx is the interval, open interval, negative 8 over by 5 until infinity. To find the derivative of fx, what do you do? Chain rule. Derivative is, well, get the argument in the denominator times derivative of the argument. So that is 5 by 5x plus 8. All right. So derivative is 5 divided by 5x plus 8. Whereas the domain is this interval, negative 8 over 5 until infinity. Let's see whether I have, there you go, infinity. Let's check. Good. Next. Suppose that fx is 13 by 4 plus natural log 3x. Find derivative and the domain. Okay. Make sure question I have copied down correctly. All right. Find the domain. First of all, denominator must not be 0. Second of all, the argument of natural log should be positive. So both have to hold true. Denominator not 0 and 3x greater than 0. All right. Denominator not 0. So move 4 to the other side. Natural log 3x not negative 4. 3x is not e to the power negative 4. In other words, x should not be e to the power negative 4 over 3. That is, x should not be equal to 1 by 3 e to the power 4. Now, 3x has to be greater than 0 implies x has to be greater than 0. This is if and only if. So you have to be a positive number, but not this positive number. So your domain is open 0 to 1 over 3 e to the 4th, union open 1 by 3 e to the 4 until infinity, both open intervals. So all real numbers except this one. Okay. To find the derivative, well, you use the chain rule, quotient rule, however you view it first. Numerator is a constant, so its derivative is 0, so it's only the denominator which matters. So minus 13 denominator squared, derivative of natural log 3x, 1 by 3x, and then derivative of 3x, 3. Okay, I hope this was all clear. You may want to use quotient rule first to see this happen, and then chain rule to take care of natural log 3x. So when you combine all of this, notice 3's cancel. You have negative 13x 4 plus natural log 3x power 2. So you have domain and you have derivative. So derivative is negative 13 over x 4 plus natural log 3x, and close that and don't forget to square it. All right. What about the domain? Set of two intervals. So let's see. Union of two intervals. 3 e to the power 4 union 1 over 3 e to the power 4 comma infinity. Okay, I hope this won't complain. Very good. We'll continue next set of problems in the next video. Until then, bye.